Assalamualaikum warahmatullahi wabarakatuh and good day. Now we continue chapter 5 with definition 7.2. So in previous video you can see that you have standard normal distribution, and then when we have y1, y2, yn follow standard normal, you can have chi-square distribution with n degree of freedom, and then you also can have when your n equals to 2 and then your z is square, then you can have chi-square distribution with n minus 1 degree of freedom, and so on. Okay, so now we have another definition 7.2. Okay, let z be a standard normal random variable and let w be chi-square distributed variable with new degree of freedom. Okay, so if z and w are independent, okay, and you have this function variable, okay, which is t equal to z over square root w divided by nu, this one will follow t distribution with new degree of freedom. Okay, so here is very important. You can see that you have this z follow normal random variable, okay, standard normal random variable, and then you have w, this w follow chi-square distribution with new degree of freedom. Then when you have z and w are independent, and then you have this function, okay, function which is t equal with z over square root w over nu. This function will follow t distribution with new degree of freedom. Okay, so actually it's a continuity from previous video lah. You can see that when you have sigma squared known or sigma known, then you will use z. Okay, you will use normal distribution. And then when you are talking about one population variance, which is unknown, you will use chi-square distribution. Okay, but here when you have the function which is consider one is a standard normal random variable and the other one is chi-square distribution variable, then it become another distribution which is called t distribution. Okay, so now look, if y1, y2 until yn, okay, is a constitute a random sample from normal distribution with mean mu variance sigma square. Okay, so you remember theorem 7.1. Okay, it can be applied that to show that the z become this one. Okay, this z has a standard normal distribution. So actually here you can see that actually we have z equal to y bar minus mu over sigma over square root n, isn't it? So this one is becomes square root n y bar minus mu over sigma. So that's why you have this z. All right. So this one in previous video you can see that this is a standard normal distribution. Okay. And then by theorem 7.3, okay, you can see that the w is equal with n minus 1 times s square over sigma square. This one has a chi-square distribution with n minus 1 degree of freedom. Okay, so you can see you have done that before in previous video. Then now you have another function which is consider this z and w. Okay, and then you know that these z and w are independent. Okay, because you proved in previous video the y bar and s square is independent. Okay, so therefore by definition 7.2 you will have this distribution function, new distribution function, which is t equal with z over square root w over nu. So this one you substitute or you replace with this equation. All right, and then this one replace with this one. So you can see that here this is z and this one square root of what is w? N minus 1 s square over sigma square. And then nu is what? Remember, nu is degree of freedom, isn't it? If you remember in applied statistics as well, you have nu n minus 1. So you will have this one. And then you simplify this one, you will get sigma square root n times y bar minus mu over s. And if you look this carefully, this one will give you t distribution with n minus 1 degree of freedom. How is it? This one actually you remember tak? Y bar minus mu over s square root n. This is the formula that you use when the sigma is unknown. You only have the sample size. Okay, I mean the sample standard deviation. So this one become t distribution with n minus 1 degree of freedom. So you can see that Okay, in previous, you just apply the formula and then how to use it. Okay, that's mean if your sigma square you didn't know, sigma you didn't know, then you will use this formula, and this formula will use t distribution. Okay, so that's why if you look figure, all right, you have standard normal, okay, the higher one, and then you have t distribution, the smaller one. You can see that, okay, here standard normal actually better lah. That's why they said that when you have a sample size more than 30, it can approximately to normal distribution. Okay, but T, it's more dispersed. Okay, you can see the figure is quite relaxed. Okay, lower than the standard normal. All right. So this is very important. Okay, you should understand or you should remember. Okay, when you have this kind of thing, what happened? But this is special. This is something special that you must remember. All right. So now look example 7.6. The tensile strength for a type of wire is follow normally distributed with unknown mean and unknown variance. So you can see that. Unknown mean, unknown variance. You didn't know sigma square. What is the value? 6 pieces of wire were randomly selected. So you know that sample n is 6. Okay, from a large roll, and then it's considered yi. The tensile strength for portion I is measured for I and from 1 until n. Okay, so that's mean you have y1, y2, y3, y4, y5, y6. Okay, and the population mean and variance can be estimated using y bar and s square. So remember, y bar is what? Summation for yi, okay, I from 1 until n. So in this case, you have 6 over 6. And then what is your s square? It become n minus 1. Oh, sorry, no. This is 1 over n minus 1. Okay, this one is 1 over n minus 1. Here will be y bar minus yi minus y bar. Okay, yi minus y bar square I from 1 until 6n. All right. The question asks you, okay, because sigma square y bar is equal with sigma square over n. Okay, this is sample means variance. So it follows that sample means variance can be estimated using this one as well. Okay, because here we have a sample mean sigma square over n. So when we have this one is a sample, okay, so we can have x square over n. So the question asks you to find approximate probability that y bar will be within 2s over square root n for the true population mu. So if you remember in applied statistics, you find this one, isn't it? But now you prove how is it you get the formula too. All right. So this is the solution. So you can see that again, you will use statistical table and formula. So again, you can see that you have this z, okay, y bar minus mu. And then the question asks you within 2s over square root n. So you must consider left and right. So right is positive, left is negative. And then this one, when you rearrange everything, you will get negative to the left side, to the right side. Okay, so you can see here. This is what? This is your T just now. Okay, so now look your statistical table, T table. Okay, instead of Z, instead of chi-square, now you look T table. So T table, if you refer your statistical table, it will give you page, table 5, okay, page 34. Okay, page 34. Okay, if you look statistical table and formula, which we use in previous applied statistic, okay, but you also can use your textbook, okay, but table 5, appendix 3, okay. So again, this is T distribution. You will have symmetric left and right, okay, and then you get the same value, but here negative value, here will be positive value. So for T, you must know your mu, which is degree of freedom, is 5. Okay. So if you remember here, is there any probability? Here. All right, 0.9. Okay. This one, when you substitute, okay, if you look here, your n equal to 5, isn't it? Your n equal to 5. So if you look here, okay, we have -2 and 2, okay, because we will consider continuity correction though, we'll get 2.015. So this one, if you look at statistical table, you will have mu here, and then you have alpha here, isn't it? All right, so now look inside here, 2.015. Your nu is what? 6 minus 1 is 5. And then you look, where is it? 2.015. So if you look 2.015, it will give you 0.05. So that one is for left and right. So since you have alpha only for this one, so 0.05 times 2, you will get 0.1. So here will be 1 minus alpha, 0.9. Okay, and the probability that y bar will be within 2 estimated standard deviation of mu is slightly less than 0.9 probability, okay, or 90%, okay. And then if you look exercise 7.24, okay, you can get the exact value of this one, okay, and then it can be found using the student's T probability and quantile, and this one using applet available. Okay, actually in your Google Classroom, I give you the link for applet ni, then you can try and play around, okay. And your assignment letter, I think you will use the applet as well, okay. So notice that if sigma square were known, the probability of y bar will be within 2 sigma y bar of mu, okay, will be given by this one, okay, 0.9544. So this one is exact value, but what we get from the calculation considering continuity correction is 0.9, okay. Now a little bit, okay, from the S square, okay, a little bit this one, but the proving will be in the next video, okay. Suppose that we want to compare the variance of two normal population based on information contained in independent random sample from two population. So now you have two population, that means you have N1 and 2 from two population. So you will have variance sigma 1 and then sigma 2. Okay. Then if we calculate S square from observation in sample 1, okay, then S1 square will estimate sigma 1 square. Similarly, if we have S2 square, calculate from observation from the second sample, and this one will be estimate sigma 2 square. All right. So it seems intuitively that the ratio of sigma 1 square divided by sigma 2 square could be used to make inference about relative magnitude of sigma 1 square and sigma 2 square. So if we decide, or if we divide each as one, okay, as I square by sigma I square, then we will have this ratio. Okay, so if you remember this one, it will give you F distribution with n minus 1 degree of freedom, okay, for the numerator, and n2 minus 1 for the denominator degree of freedom. So generally, we can say that this one will give you F distribution. Okay, so the proving will be discussed in the next video. So here you must remember, okay, very important in chapter 5, you know the correlation between, or not correlation lah, the continuity, okay, but all this come from what? Standard normal or normal distribution. So I think that's all for this video. We'll continue next video for the proving of this F distribution function. Thank you, class.